SOLIDWORKS has tools that let you use equations in your designs. For instance, you can use equations to control dimensions, and you can also create 2D and 3D equation-driven curves in a sketch. However, there isn't a tool that lets you create a surface directly from an equation. Fortunately, there's a pretty simple workaround that you can use to create a surface governed by an equation. It's by drawing initial curves from XYZ points and using them as guidelines for a boundary surface. For this example, I'll use the equation y equals x to the fourth times sine x minus 5 times x times z to the fourth. In order to create curves through XYZ points for this equation, I will use Microsoft Excel to generate the values of x, y, and z to use as data points. When creating the Excel file, make sure the columns are in that order: x, then y, then z. I'll choose 5 values from negative 0.5 to 0.5 for z to hold constant and create 5 separate Excel files for each value. Creating more Excel files will give you better results, as the resolution of your surface will be much higher. But using more files will also take more time to calculate and create. For each value of z, I'll choose values of x and calculate the result of y. I will use values of negative 0.5 to 0.5 by increments of 0.05 for the value of x. Again, a smaller increment will produce more accurate results, but takes more time to calculate. You should find an increment that is time efficient and still creates the surface with the resolution that you wanted. I'll enter the equation into Excel for y, linking the cells to calculate the value. That completes the curve for z equal to negative 0.5. For each Excel sheet, I will save the file type as a text tab delimited file. I'll create the second Excel file the same way, but now I'll use negative 0.25 for z. Because I've linked the x and z cells in the equation, you can see the y column automatically updates. And again, I'll save it as a text tab delimited file. I'll have to repeat this process for the rest of the z values in the range I need. To save time, I've already created the Excel files for the rest of the z values. I use the same process, but for z, I use the values 0, 0.25, and 0.5. Now back in SOLIDWORKS, I'll start a new part. I'll go to Insert, Curve, then Curve through XYZ points. Next, I'll browse for the text files for one of the z values and select OK. I'll repeat this for all of the text files I've created. Now that all of the curves have been inserted into SOLIDWORKS, I'll connect them with the spline. To do this, I'll start a 3D sketch from the Sketch tab. Next, I'll select the Spline Sketch tool and connect the ends of all the curves on one side. I'll also repeat this for the other side of the curves. Finally, I'll insert a boundary surface by either clicking the icon under the Surfaces tab or going to Insert, Surface, and selecting Boundary Surface. For Direction 1, I'll select the curves I imported and for Direction 2, I'll select the two splines I created. I'll finish the surface by clicking the green check. You can see the surface for this equation. If you need a more accurate surface, you simply have to create more curves in Excel. The more points you have imported as curves from Excel, the higher the resolution of your surface will be, resulting in a more accurate model.